In this video, we're going to put the follower right here into the Automata assembly, and we're going to test it out with an elliptical cam. So we're asked to make a new assembly called follower subassembly, and then we'll put that into the Automata subassembly and go from there. So let's go here to where we made the part studio that consists of two parts, the follower shoe and the follower rod. So I want to click plus, create an assembly, and then we're going to rename this follower subassembly. Okay, so we'll say insert, and then we're going to come down to the part studio, and mine is going to be this one here. Yours should just be called follower, I think. All right, so now that we're here, right, of course this isn't mated yet, but we can fix that by just grabbing it in the graphics window like that, and then using the awesome group command, and now we've got a fully mated follower system. So we can put this into our automata, which is right here. So we'll say insert, assembly, and I think it's still generating the view here, but if I click, I can place it. So we're going to put 5 of these in here eventually, but for now I just want to put 1. And the type of mate we're going to have to do is a slider mate. And so it's going to slide in this leftmost hole here. So to apply that, I'm going to first choose the follower rod right at the top of the shoe. So I'll click there, like so. And then I'll come over here and match it up with that hole like so. And if I click the front view, well, that doesn't look right. What happened there? Let me redo that. So slider mate right there, and then right there, and I'll accept that. And the front view looks like that. Okay, I'm going to put some limits on here. You might have to play around with this for a little while. For me, I included what worked for me in here. So the distances that we're going to have it be limited to is 0 and minus 3.75, and where I got that is, if you look at what we're trying to do is keep it in this area where that magenta line is, and so the distance we have to go is at 1.875, but this is already 0.75 thick. So this thing, when it's here, it can only go, I hope you can see, 1.875 minus 0.5, so 1.375, and then the tip of this will intersect with the top of the axle, so 1.375. So you can work that out on your own if that's not immediately clear. And then depending on how your mate came together, you'll have different values here, but this is what's worked for me consistently: minus on the top and then 0 on the bottom. And the way I can check that is to animate it. And let me speed it up a little bit, and I'll test it out. And this time it didn't do that. So let me, I didn't put any limits on it. Minus 1.375 and 0. And let me animate it again. 100. Okay, so that's correct. So I think I accidentally added another slider mate there. Okay, so that's all set up. And now to test it, you'll remember it rides on the cam up and down. Let's go ahead and test it with the elliptical cam. So I'll put it in there, and you'll notice that it looks kind of big, but let's just go with it. So to attach the cams to the axle, what I'm going to do is I'm going to hide the axle collar, and then I'm going to mate these using a fasten mate because I want it to be rigidly attached to the axle with no rotation, and it should be flush up against the wall here, and then I can use offsets to bring it down. So I'm going to use a fasten mate here, zoom up right in the middle of this hole, and then come around here, and I want to put it right there. And then I can front view. So I want to switch the primary axis, flip the primary axis. So I want it right next to the wall. Okay, but I need to slide it down by a distance over here. So let's see what that distance is. And I hope you'll believe me when I say that going from here to here is the distance I want. And you can see that that's 1.375 again. Okay. So I'm going to put an offset here about the z-axis, 1.375, and it's got to be negative, like so. It's right underneath, so I'll take that. And now I've got a system here, and I'm ready to test it out. So let's do it. Boy, that looks pretty big, doesn't it? So let's animate, not isolate, animate the, let me back off here. Why does it do that? Let's animate the revolute mate, and we'll loop, and there it goes. And you can see I might have a problem here. My cam is too big. There's no way that's going to fit. So let's stop and regroup. And the way to do this is another awesome tool for Onshape and assemblies. If I right click on my cam here, one choice is change configuration. So if I click there, since we define things in terms of these configuration variables, I can change it right here. So I'm going to change it from 2.5 to 1.5 and generate, and you can see it shrank. There we go. That's a little better. All right, let's actually test, do our first test for the Automata. So here's what we need to do. We're going to put a tangent mate between the face of this shoe, and for some reason it's got to be on the edge of the cam rather than the face. So put it on the edge and accept that, and we've got our first setup. We're ready to test. Let's go ahead and animate the revolute mate, speed it up a little bit. Let's speed it up a lot, and we'll say loop, and we'll run it. There we go. Let's speed it up even more. How about if we do 20? There it goes. So you can see that it's the cam follower. So again, the location of the linear motion of the follower is really the output of the machine. That's what we're engineering. And you can see that it pretty much just goes up and down kind of in a smooth way. And we're going to quantify that in a subsequent activity and compare it to the motion of the follower when we have different types of cams along the axle. Thanks for watching.